Alright. The point of this exercise here is to find the set of all points that are equidistant from two given starting points. So first we have to plot our two given starting points, and to do that, well, we need to put down some x and y axes here. This ruler is a little bent up. That's not going to be the best, but it'll do. So there's an x-axis, by the way. I've got my paper, or so that's a y-axis. Our paper is set up landscape style. You should have plenty of room to set your, little bump there. Okay. Should have plenty of room to set it up kind of how you want it. Okay, so our first point is 1, 3. Let's see. Over 1, up 3. That's point A. Our next point is 4, 7. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. That is B. And, oh, wait a minute. No, that's C. That's all wrong. That's C. And B is 7, 3. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. That's B. Alright, so first thing we're supposed to do is we're supposed to show that point C is equidistant from point A and B. And we should be able to, by this point, do this calculation pretty easily. So let's see. From A to C is up 1, 2, 3, 4, and over 3. So let's see, it's 4 squared plus, so we got 4 squared, all right, over here. Let's see, plus 3 squared equals C squared. We do all the math here. You should have seen this before. 25 equals C squared. So 5 equals C. So this distance here is 5. And this distance over here, 1, 2, 3, 4, 1, 2, 3, is also 5. You use your Pythagorean theorem. So we've shown that point C is the same distance from point B as it is from A. So the distance from C to A is the same as the distance from C to B. Now we're supposed to find all the remaining points on the grid that are the same distance from A as they are from B. So let's see if we can find some more. Well, obviously there's the one right here in the middle, right? I'll change colors here. One right in the middle, right? This is 3 units from A, 3 units from B. And notice how this makes this sort of isosceles triangle shape here. So that point there, that'll be the same distance from A as it is from B, as with this one and this one. Of course, we're not limited to points that are above. Go down here, right, or down here. All these points are the same distance from A as they are from B. This just makes that isosceles triangle shape. No big deal. Of course, it's not just the points that are right here, the lattice points, but also the ones in the middle, like here, 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 all of these. We could make this sort of isosceles triangle by connecting them to A and B, and they'd be the same distance from A as they are from B. So in fact, we can go ahead and make a line that just cuts all the way through the grid, right there. We're going to give this line an equation. Notice it's 1, 2, 3, 4. It's all the points that have x-coordinate of 4. So like 4, 1, 4, 2, 4, 3, 4, negative 1. So the equation for this line is x equals 4. Alright. Now, this, by the way, I want you to notice, this line here, it cuts our original segment from A to B. Cuts it in half, and notice that it forms a right angle with segment AB. So it's perpendicular to the segment that has endpoints A and B, and it's perpendicular to it. Alright, so now you're going to go down here into the third quadrant, and you're going to plot points D and E, and then F, and you're going to do the same thing there. I want you to find the distance from D to F and distance from D to E and show that they're the same. and then find all the remaining points that are the same distance from D as they are from E. I think those points were 1, 2, 3, 4, 5, 6, 7 down to, I think this was D, and F was down, or E was down 1, 2, 3, 4 down here. Okay? And F, I think, was back 2 down 1, 2, 3, 4. So there's F. Okay? So you're showing that point F is the same distance to E as it is to D, so you're going to calculate those distances. And I just want them labeled. You don't have to show both calculations because it's going to be the same calculation both times. So just show the calculation once, and then just label it on both segments, and then find all the remaining points and give the equation for the line. All right, good luck with that.